Hello. Glad you're all here. Let's get started where we left off. So we're on chapter 2. You do have your first exam on either, it starts Sunday at like 5 a.m. and you can take it all the way until Monday midnight. Once you start it though, you got to finish it. You can use notes. So feel free to do that. We will be finishing up nomenclature today. I do recommend that you get the quote unquote lab done for this week before you take the exam. So the lab is not, it's not actually a lab. It's a homework assignment in Mastering Chemistry that's specifically over nomenclature. So just make sure to get that done so you can get like instant feedback on if you're getting nomenclature. Nomenclature just being naming. Okay, so let's begin. All right. So we left off talking about writing chemical formulas for ionic compounds. Okay, so when we have a metal mixed with a nonmetal, that is our defining quality of an ionic compound. We need these, this metal and this nonmetal to combine in a charge neutral way. And the fastest way to do that is to take the charge of your metal and put it as the subscript of your nonmetal, take the charge of your nonmetal and put it as the subscript of your metal. So we flip flop accordingly. Or the charge on the cation becomes the subscript of the anion, the charge on the anion becomes the subscript on the cation. So remember, go back here, when we're looking at our periodic chart, there are things that have predictable charges. So column 1, +1, column 2, +2. Transition metals kind of do funky things. Aluminum is a +3. Remember, go in our zigzag, this is 3, zinc is +2, silver is +1. 3, 2, 1. Nitrogen, 3-. Column 6 is all 2 minuses. Column 7 is 1-. And noble gases, you can just put, I like to sort of put like a 0 with a strike through it or something because those don't form a charge. Their charges are neutral or 0. So let's do a couple flip-flops. I'm going to tell you some things I want us to combine, and then you will combine them. Oh, we did talk about cations, different polyatomic ions, common anions and polyatomic ions. And remember, a polyatomic ion is just a grouping of atoms that has an overall charge, okay? Important to note that all of the atom packets have this plus charge. In this case, all of these SO4, this whole packet of atoms has this 2- charge. So the charge is included throughout the entire molecule. Okay, so I'm going to give you some things to name. Or not name, rather. I'm going to give you some things to write a formula for. Okay, so I want you to combine aluminum and sulfur, magnesium and fluorine. I'll give you guys a couple more here. What do I want to do? Sorry guys, pulling out a periodic chart. Okay, there we go. Potassium and nitrogen. And let's do one more. We'll do cesium and bromine. Okay. So I want you to combine those two materials using your flip-flop method to make a formula. And your formula needs to be charged balanced. Just another 30 seconds, and then we can go through these. All right, so the first thing you need to do is identify, when you're trying to write a formula for these, is identify that it is in fact a metal and a non-metal. If it's two non-metals, like if it was carbon and oxygen or nitrogen and fluorine, we wouldn't use this balancing system, okay? It has to be a metal combined with some sort of non-metal or polyatomic ion. So this is a metal, magnesium's a metal, potassium's a metal, and cesium's a metal. So we know for all of these, we can follow that flip-flopping. Another thing you want to make sure of is, does this thing have a predictable charge or an unpredictable charge? All of these things have predictable charges. The things that have unpredictable charges are all those transition metals in the center. They have varying charges, except for aluminum, zinc, silver. All right, so we've got aluminum. So the way I want you to solve these is you write down the symbol for aluminum, Al, and you write its charge. Now we know that aluminum will always have a 3+ charge. Okay. Sulfur, symbol is S, and sulfur is under the column that has the 2- charge, right? So now we take this number, we drop it down for the aluminum, we take 3. We take this and drop it down for the sulfur. So it should become Al2S3. Okay, again, this gets dropped down here. This gets dropped down here. You don't take the charge with you, nothing like that. And if we want to go back and make sure that this thing is in fact charge neutral, well, what's the charge on aluminum? It's 3+, and there's, and you have 2 of them, okay? Plus whatever's going on with the sulfur. Sulfur is a 2- charge, and you have 3 of them. So this overall equals 0, charge neutral. You don't have to check it every time, but just to get an idea. All right, next one, we've got magnesium and fluorine. So magnesium is in column 2. So I know that this is going to be Mg with a 2+ charge. Fluorine, F with a -1 charge. I'm not making these charges up. These are the charges that hopefully you have written on top of your periodic chart that you just get to reference. So I flip-flop. So this tells me 1 magnesium for every 2 fluorines. Again, this whole thing is now charge neutral. And you may be thinking, oh, well, obviously, if magnesium's a 2+ charge and fluorine's a 1- charge, I would need 2 of these to balance out 1 of these. You can think of it like that. Really, the easiest way is to flip-flop. If I look at potassium, potassium is K, not P, and this has a +1 charge. Nitrogen, N, has a 3- charge. Flip-flop. We should end up with K, 3, and 1. Cesium and bromine. So cesium is number 55. It's in column 1. CS, it's got a +1 charge. Bromine, Br, has a -1 charge. If we flip-flop these guys, we end up with a 1-to-1, CsBr. Okay? So if I'm combining cesium and bromine, they will always come together in this formula. There's no other way for them to come together. If aluminum and sulfur are coming together, this is always going to be the formula that you come up with. There's only one right answer for it. Any questions on those?
I have a question regarding how do we know which element to write first in the equation?
You will always write the metal first. Yes, so great question, Brittany. So write the metal and then the non-metal. If you're in a situation where you have 2 non-metals, which we'll talk about a little bit later, you always write the more metal-like thing first, or the thing that's closer to the zigzag line. Okay, great. So hopping back over to the PowerPoint here. Okay, so an ionic compound is when we've got a metal combined with a non-metal. We flip-flop to get our formula. You know what? Let's do this with polyatomic ions as well, since we're here. Okay, so look at sulfate. Sulfate is SO4 2-. So we'll go back over to our board, and I'm going to add another text here. This time I'm going to combine aluminum with sulfate. aluminum with sulfate. Let me move you. Oh, come on. It's just good. Okay. So when I have aluminum with sulfate, in this case, I have a metal and I'm combining it with a polyatomic ion. The system is going to be very similar to this. So what I need to do is write my symbol for aluminum, Al, with a 3+, and then I need to write my sulfate ion. Now, so you all know, when you're dealing with a polyatomic ion, anytime you see an ATE at the end or an ITE, that's indicating the polyatomic ion. Reference a polyatomic ion sheet. Okay, so for your next test, make sure you have a polyatomic ion sheet on hand. There's one in the textbook. You can also print one off of Google, just polyatomic ions, and it'll give you all of them. Okay, so sulfate is SO4 with a 2- charge. So sometimes what I like to do is circle where the atoms are, okay? Because I want to remind myself that those are a packet or a grouping. Just like I wouldn't break the A and the L apart, I'm not going to break the S's and the 4 oxygens apart. So this whole thing is a packet. This whole packet has a 2- charge, all right? So when I go to flip-flop, and you know what, I'll circle my aluminum as well. So when I go to flip-flop, the charge is going to drop and apply to the entire packet, all right? So 2 is going to come down for the aluminum, so aluminum gets the 2. Sulfate gets the 3, but I need to put it in parentheses. Because what I'm saying is the entire sulfate packet, I have 3 of those in order to get my charge neutrality. So I'm going to give you a couple with a polyatomic ion, and I want you to do them on your own, okay? Let's do...
The only polyatomic ions that I have written down are ammonium and sulfate. Do you know what page on the book?
let me see. Got the text here. This says it's in chapter 2. So if you go to page page 68, has a bunch of the anions. So you'll see you've got like acetate, chlorate, perchlorate, nitrate, permanganate, carbonate, chromate, sulfate. And on the page before it, or 2 pages before it, page 66, it's got really the only positive polyatomic ion you guys are going to see is ammonium, which is NH4+. Okay. And we're going to talk a little bit more about polyatomic ions and how you can sort of derive like nitrite from nitrate in a little bit. But for now, if you want, you can just reference page 68 in your text. I'll just use whatever's on there. Okay, so I'm going to say calcium carbonate and barium acetate. Again, if you don't have your textbook right on you, just look up what carbonate is and look up what acetate is. And I'll give you one more, why not? Oh, hello. Let's do aluminum nitrate.
The fuck? I just.
Brittany, your speaker's on, just heads up.
Sorry.
It's okay.
I mute myself.
Give everybody a good laugh for the day. All right. So for this first one here, I've got calcium and carbonate. So my calcium is always going to be Ca with a 2+ charge. Carbonate is always CO3 with an overall 2- charge. Again, if it helps you with the polyatomic ions, think of them as a packet, and I'll think of that as a packet as well. So in this case, I'm going to flip-flop. It's going to drop to a 2 and a 2, but I can always reduce that down to a 1 and a 1. So this thing ends up being CaCO3. CaCO3. That's supposed to be barium. Sorry. You're wondering what barium is. I meant barium. So put an R in there. So barium is Ba with a 2+ charge. Acetate is one of your polyatomic ions. Again, if you see, you know, ATE, ITE, you want to reference your polyatomic. So we've got C2, H3O2, 3O2 with this thing having an overall minus charge. That is a mess. I'm just going to rewrite that. Okay. So again, you can sort of pack it off your polyatomic, leave the charge on the outside because that's including everything. And we're going to flip-flop here. So the 2 needs to get dropped outside the acetate. The 1 needs to get dropped outside the barium. So barium, we only have 1 of those. Acetate, I should have 2 of them. So I'm going to put it in parentheses, C2H3O2. 2 with a 2 on the outside of it. Right, that would be the formula for barium acetate. For aluminum nitrate, aluminum is Al3+, always 3+. Nitrate is NO3 with a minus charge. Packet it out. All right, and now we're gonna flip flop. So 1 aluminum for every 3 of our nitrates. This is where some people, they are like, they don't wanna write 2 3s next to each other. So, but it's okay. So we write our NO3 parentheses 3. We have 3 of these packets. What I don't wanna see is AlNO3. You just sort of smush them together. Doesn't work. You've got a charge balance. Also don't wanna see this, AlNO3, 3. Because I look at that and I'm going to see aluminum with 1 nitrogen and how many oxygens? 33 oxygens. That is also not correct. So make sure you're using your parentheses. You need them. Okay. So with a polyatomic ion, it's very similar to just a metal and a non-metal. You just have to make sure that you, if you need to pack it out, your polyatomic ion, you do so. Parentheses, though, you only use if you have more than one of them. So like with calcium carbonate, I didn't write my calcium carbonate with parentheses around the carbonate. I just wrote it as the calcium with the carbonate. Questions on that? I'll show you online real quick. If I just type in polyatomic ion list, I'm gonna find all sorts of things on there for you, okay? So you just pick one that works for you. All sorts of polyatomics. How many polyatomics are there? There's a lot of polyatomics. And you don't have to have them memorized. All right. So now that we are good with neutralizing charges for metals and nonmetals, we're going to talk about this thing called chemical nomenclature. So nomenclature is just a fancy way of saying naming. So in chemistry, because there's so many chemical formulas out there, we have to have a consistent way to name these things. Otherwise, you would have to memorize the name of like every single formula. And there are thousands and thousands of formulas. So instead, we follow this systematic approach. We want to be able to divide our things into ionic compounds, molecular compounds, acids, or is it an organic? So in your Moodle, there is a flow chart that I find really, really useful when it comes to naming, because the way that you name ionic stuff or a metal and a non-metal is going to be different than the way that you name a molecular thing, which is 2 non-metal things. So if you go to your Moodle page and you go down into chapter 2, you'll see this thing here called nomenclature flow chart. That thing is right here, okay? So this is how you're gonna approach naming every single time you've got a formula. So you start at the very top and you ask yourself, is there a metal on the left-hand side? So pretty much you're saying, is it ionic? And if the answer is yes, you're gonna move in this direction. You have a salt, you have a cation or a metal combined with an anion or a nonmetal. We're going to use Roman numerals for a charge if it's a transition metals, and we use the flip-flop rule to balance the charges. As far as, and actually there are polyatomics on this little flow chart here for you. So this may be something useful for you to print out or have accessible during your test. So right now we're hanging out over here, okay? We're gonna get to this side over here in a minute, but let's just focus on how we get these salts named. It's pretty simple. So when we're writing the name, page 44 on lab manual, there's a polyatomic ion sheet on there. I'm guessing is what you're saying, Rachel. Yes, no, maybe so. Okay, throw it in the comments if you do. So we always write the name of the cation or the metal first, if the cation can have more than one possible charge, you have to write the charge in a Roman numerals in parentheses. So all those transition metals, you have to specify which iron you're using or which cobalt you're using. So if I'm using sodium, because sodium's in column 1, it has a predictable charge, I would just write it as sodium. But iron has an unpredictable charge. It's in that middle area, that gray area. So I have to, in Roman numerals, say that I'm working with iron 2, or say that I'm working with iron 3, or iron 1, or whatever it happens to be, okay? And this number is letting me know the charge, not how many I have. If for some reason it's a polyatomic cation, it will end in IUM. Really, the only polyatomic cation that we see quite a bit is ammonium, which is NH4+. This is ammonium. All right, so we write the cation first. If the anion is an element, we will change the ending to IDE. If the anion is a polyatomic ion, just write the polyatomic ion. So let's go back to our whiteboard and name those things that we are working on over here. So we'll leave the polyatomic ions for a second. We'll go back to those simpler ones. Okay. So I'm looking at this thing here and I want to name this. So first I determine, is it a metal and a non-metal, or is it 2 or more non-metals? This is a metal and a non-metal, so I get to use my system where I start first by writing the name of the metal. So I go aluminum. Then I look at the second thing and I determine, is this a polyatomic ion or an element? It's an element, so I would write the base name of sulfur, which is sulf, and then I would IDE the end. So this thing is called aluminum sulfide. We don't call it aluminum sulfur. Here I just said we were combining aluminum and sulfur, but if I was to write its name, its nomenclature would be aluminum sulfide. Okay, this here, I've got magnesium mixed with fluorine. So I name the metal first, magnesium. And then I write the base for fluorine, which is fluor, and then IDE, magnesium fluoride. The base names is in the text. So it's sulf, fluor, nitr, brom, ox, so on and so on. So here we've got potassium and nitrogen. So this would be potassium nitride. This one here, cesium bromide. Okay, the IDE is referring to the element version. So that's just how you're always going to name those. If you've got a metal with a non-metal element, say the metal, say the base of the second guy, and just item. All right. If you have it as a polyatomic ion for your second thing, which we've got going on here, all you do is smush the two together. So I would call this thing here aluminum sulfate. This one would be calcium carbonate. This would be barium acetate, and this guy would be aluminum nitrate. All right, you don't IDE polyatomic ions. Leave the polyatomic ion as it is. Now, in those notes, they said something about changing. Let me clear this out. A little crazy. So they said something about if the cation can have more than one charge, write the charge as a Roman numeral in parentheses. So I'm going to give you an example of this, or I'll give you a couple examples. And also here we can see it says use Roman numerals for charges of transition metals, things that vary. All right, so FeO2. The 2 is a subscript 2, okay? So I know that, just think of that as a little 2, like FeO with a little 2. Let's do CO3 N. Let's do NiN, and we'll do, let's do another Fe, and this time we'll do Fe, we'll just do FeO. Okay. Plus the period. If you hit the Windows key and the plus and the period key, you can get access to a superscript and subscript characters along with a bunch of other symbols. Oh, cool. Try that out. Oh, don't hit the plus key. Okay, so hit the Windows key and the period key. Okay, emojis. Isn't that nice? Don't really need emojis though, huh? Symbols. I'll have to look it up. I will look it up at some point. Okay, I'm going to do one more Fe2. Oh. All right. So I'm going to go through a couple of these. So that first guy there, we want to name this thing. So I'm looking at it, and again, it's FeO2. Okay. So I see this thing, and I can see that there's a metal and a non-metal. I'm always going to write the metal first. So right away, I'm going to write iron. But I know that iron is one of my transition metals. It's one of the guys that sits in the middle here that doesn't have a nice, neat, predictable charge. So right off the bat, I'm going to put a Roman parentheses here because I know I'm going to have to fill it in with some sort of Roman numeral to let me know what the charge is. What is oxygen? It's just oxygen. So we're going to say oxide. All right. So now we have to go ahead and figure out what the charge is on this iron. Well, you go from what you do know to get what you don't know. We know this whole thing has to equal 0, right? Because these are charge neutral. What is the charge on oxygen always? 2 minus, and how many of them do we have? 2. So we have a 2 minus charge times 2, or we have an overall 4 minus charge. Why? Because each oxygen gives you a -2 charge. So if this is a 4 minus charge here, sometimes I'll even put like a little dash between them. If this is a 4 minus over here, this has to equal a 4 plus charge. So So my iron is going to be Roman numeral 4, or iron 4 oxide. All right, next one here, I've got cobalt 3 with a, or cobalt with a 3 and then nitrogen. So I know that this is cobalt. By looking at my periodic chart, I know I need a Roman numeral because it's in the middle, and this is nitride. So I need to figure out what my charge is on cobalt. Well, nitrogen, I mean, the whole thing has to equal 0, right? Nitrogen always has a 3- charge. So this has to be a 3+ charge. But how many cobalts are there? There's a total of 3 cobalts, right? So each cobalt will bring you a +1 charge. So this would be cobalt 1 nitride. Okay, NiN is not an awesome band from the 90s, but nickel has an unpredictable charge. So we need a Roman numeral, and this is, again, nitride. I know that nitrogen or nitride always has a 3- charge. I only have one of them. So the nickel has to be a 3+ charge. 3+ charge. 1, 2, and 3. I want you to do the last 2 on your own, okay? We've got FeO and Fe2O. Now they're both going to be iron oxides. You just have to determine what the charge is of each of those irons. Okay, so both of these are iron oxides. The one at the top is also an iron oxide. So when I refer to, hey, iron oxides, I'm actually talking about a group of possible compounds. So this thing will write iron oxide. And actually for this one, I can also write iron parentheses oxide. For this one, when figuring out the charge, oxygen has a 2- charge, so the iron has to be a 2+, and there's only one iron, so all that 2+ is on one iron. In this one, I'll put a line through it, this is a 2- charge, this is a 2+ charge, but it has to be distributed amongst 2 irons because you have 2 of them, so you always divide it by the subscript when you're going down. You multiply it by the subscript when you're moving up. You divide it by the subscript when you're moving down. So 2+ divided by 2 irons gives me iron 1 oxide. This same thing works with polyatomic ions. So if I gave you Cu2SO4, all right. One rule of thumb, whenever you're going to name and you're like, oh God, how do I name that? What? It's like a copper sulfur oxide thing. I don't know. It's probably a polyatomic ion. Okay. That's like 99% of the time when you're like, it's not matching the rules. It's because it's a polyatomic ion. So in this guy here, we've got copper and we've got sulfate. So I'm going to write copper. I'm going to put in a parentheses because I know copper has an unpredictable charge. And then I'm going to write sulfate. Now, Just like you would divide this up, I'm going to divide this up between my metal and my non-metal side. Sulfate always has a predictable charge. Sulfate's charge is always, always, always 2 minus. So what is my copper going to be? It's got to be a 2 plus. Okay, but how many coppers do I have to distribute that between? I need to distribute it between 2 coppers. So I take my 2 divided by the 2 coppers I have, and I get a 1, or copper 1 sulfate. I'll give you guys another one with a polyatomic ion in an unpredictable charge. Let's do AU parentheses NO3 2. It is, Rachel, it is necessary to put the Roman numeral 1. Yes. If you just leave it off, I'm going to assume that you think that's a predictable charge metal. Okay, so keep the Roman numeral 1 on there. Good question. Okay, so this guy here, we've got gold. Going to have an unpredictable charge, and I've got a polyatomic ion called nitrate. All right, the line here, nitrate is always a -1 charge, but look at how many of them I have. I have 2, so I've got to multiply it by 2 for an overall 2 minus charge. That makes this side a 2 plus charge, and it's only distributed over 1 gold, so it is in fact a Roman numeral 2. So we would call this gold 2 nitrate. A pitfall I see sometimes is getting this mixed up with our predictable charges. Okay, so when I write something like this, Li2CO3. It's a metal, it's a polyatomic ion. And what I have happen sometimes is students will go like this. They'll go Li, lithium, Roman numeral, carbonate, and then they'll figure out, okay, well, carbonate is a 2 minus charge, so this has to be 2 plus, and it's distributed over 2, so this is lithium 1 carbonate. Why is that wrong? Because what is lithium's charge always? Look at your periodic chart. Lithium's charge is always a +1, so you don't put that in there. It's redundant information. So instead, we would call this thing just lithium carbonate. All right, so only use the Roman numerals when you're dealing with unpredictable charges. Great. So, yep.
Would we ever see these types of formulas with like any of the metalloids?
Treat them, I would just treat them as nonmetals. You might see it with like silicon and just treat it as a nonmetal.
And then just for ultimate clarity, the things that we would be using the Roman numerals on are anything like in rows 3B through 4A, except for what, aluminum, zinc, and
silver.
Silver.
Yep, perfect. Yeah, so lead and tin, those guys that are sort of nestled over there, you're going to want to use Roman numerals for those. All right. Perfect. Great. Good questions. All right. So patterns of oxyanion nomenclature. So all this is saying is give you a little help with like your eights and your ites. So if you know your 8, like nitrate here is NO3 minus. To get to my ite, I just strip 1 oxygen away. All right, so if I know nitrate is NO3 minus, nitrite is going to be NO2 minus. Sulfate, the ATE doesn't mean that it has 3 oxygens. It could have 3, it could have 4, it could have more than that. But in this case, sulfate, ATE, SO4, 2 minus. If I want to go to sulfite, I strip an oxygen away, it becomes SO3, 2 minus. So that's a nice way to connect your 8s and your ites. Ites will always have 1 fewer oxygen, 8s will always have 1 more oxygen, charge stays the same. So central atoms on the second row have a bond to at most 3 oxygens. Those on the third row can take up to 4. Okay, so carbonate with carbon and nitrogen being in that second period, they're going to have 3s as their starting point. Your period 3, or where your phosphorus, sulfate, and chlorine is, they can have 4. So we said ite has 1 fewer, 8 has 1 greater. If you have 1 less, like if we're looking at chlorate and chlorite, or we can see them here, here's chlorate and here's chlorite. So chlorate in this case has 3 oxygens, chlorite has 2 oxygens. Let's say we stripped another oxygen away, we would call it hypochlorite. Hypo being under, right? So hypoglycemic. So hypochlorite, 1 less oxygen than your ite. Then you go to 8. If you had 1 more oxygen, it would be perchlorate. Okay, so per meaning more. So our per 8, then ite, then hypoite is the ordering that you can stretch out. So that's one way to get to know the oxyanions. And when they say oxyanion, they just mean an anion, a negatively charged thing that has oxygen and something else in it. So going back to that flow chart, all right, so if there's a metal, we can go in this direction. We've covered all this. If we happen to be 2 nonmetals, we're going to go to the right of the chart. And the next question we want to ask yourself is there a hydrogen on the left-hand side? If the answer is yes, we are going to define this as an acid, and we need to name it accordingly. All right, these techniques, these skills, we don't use over here. All right, so if there's a hydrogen, we classify it as an acid and we name accordingly. If it doesn't have hydrogen in it, this is a molecular compound, and we'll get into that in just a second. So acid nomenclature. So if the anion in the acid ends in IDE, like this, for instance, we've got hydrogen and chlorine. So if you have hydrogen mixed with just one other thing, the way that you're going to name this is you're going to write the word hydro, the base name of the nonmetal, so this would be chlor, you ick it. Okay, so hydrochloric acid. Here we've got hydrobromic acid. Here we have hydroiodic acid. So pretty simple when we're dealing with hydrogen and one other thing. If we are dealing with hydrogen and it is combined with a polyatomic ion, it's going to be a little bit different, okay? So let's skip this first one here. If we have, like in this case, we have hydrogen and it's combined with the polyatomic ion ClO2, which is chlorite. Ite goes to us, ate goes to ick. So one way to remember it is you ate something icky. All right. So for this one, I have chlorous acid. You don't use the hydro. You only use the hydro when you're dealing with hydrogen with one other thing. If it's a polyatomic ion is your second thing, we don't include the hydro, okay? So this becomes chlorous acid. If you're dealing with a hypo situation, like this one, this would be hypochloric acid, we would call it hypochlorous acid. If instead your hydrogen is mixed with any ion that ends in ATE, the ATE becomes ic acid. So here we've got a hydrogen mixed with chlorate, so this becomes chloric acid. Here we've got perchloric, so we include the perchloric, so this becomes perchloric acid. Sorry about that. So giving another one of these, try this one out, HF. What would we call HF? HF is a nasty, nasty acid. So it's a hydrogen combined with just one other thing. So we do need to include hydro. We've got hydro. We take the base name, fluor, we ick it, and we add acid. Hydrofluoric acid. HS, there's really only so many of these in this first one. HS is a little different. This one we call hydrosulfuric acid. We use the full name of sulfur, and as opposed to hydrosulfic acid. If I have something like this, let's do HNO3. This is hydrogen combined with nitrate. Okay, so I'm going to use this pattern over here. This would be nitrous, or I'm sorry, my bad. Where I've got it written is a little confusing. Let's just clear that out. We'll rewrite it down here. Okay, so I've got HNO3. This is nitrate. 8 goes to ick, so this becomes nitric acid. If I had HNO2 instead, this is nitrite. Nitrite goes to us. This becomes nitrous acid. Nitric acid, nitrous acid. Questions, comments?
On the nitrous acid and the nitric acid, is it still hydro?
We don't use hydro. We only use hydro when it's one hydrogen combined with one other thing. If there's a polyatomic ion, ditch the hydro.
Okay.
Just don't use it. Yeah, we don't call it hydro nitrous acid. We just call it nitrous acid. Okay, the hydro only goes for, these are called binary acids. These are called oxyacids. So a binary acid is just when you have two things, like a binary star system. Oxyacid is when you have an oxy anion in it. All right, so one more thing I want to get through here. So what do we do if we have two nonmetals? And we are not an acid, okay? So again, going back just to tie it together with that flow chart so we can check everything off of it. Somewhere, there you are. Okay, so we have done this here. We know how to do our salts, our metal and our nonmetal. We've gone, well, what if we have two nonmetals? We know how to name our acids. Now, what if we are two nonmetals, but we don't contain hydrogen? This is where we have to use prefixes, and this is where it gets tricky. This is why I want you to use the flow chart, because sometimes people want to use prefixes over here and vice versa. So you've got to make sure you're using the right tools. So when naming a binary molecule or two nonmetals, we'll name the element farther to the left of the periodic table first. So the thing that's closer to the metal side, we name first. A prefix is used to denote the number of atoms on each element in the compound. Mono is not used on the first element, however. I'll show you guys that in a second. So here are all the prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Some of those should sound familiar, right? Di, two, tri, tricycle, tetra, tetrahedral, penta, pentagram, five, hexa, right? Hexagonal. So those are all of our prefixes. So we will sort of just smush those in front of it. So I'm going to give us some examples here. All right, so if I write SO2, the name for this is sulfur dioxide. All right, non-metal, non-metal, I use prefixes. No hydrogen, so we don't name it that way. If I write this, SO, this would be sulfur monoxide. We do use mono on the second guy. We don't use mono on the first guy. It's the one exception to the rule, okay? We can see another one here, CO2 versus CO. This thing is carbon dioxide. This is carbon monoxide. We don't mono the first guy. But let's say we had something like this, C2O. This I would call dicarbon monoxide. We can't drop 2, 3, 4, 5, 6, 7, 8. We can only drop one, only on the first guy. So this is the one that'll make you like sound kind of smart with your friends, because you can be like, oh, that's tricarbon, you know, diheptide or whatever. So let's do a couple of these. I'll give you a couple and I want you to work on them. Okay. N2O4, P6, BR3, Si2O2. I think these ones are a lot easier to do than the metal and the non-metals. You don't need to flip-flop charges. You don't need to balance anything. You literally just look at it, write it out. Okay, so for this first one, I mean, again, the first thing, and whenever you're naming, is you want to ask yourself, you know, is this a metal and a nonmetal? Is there a polyatomic ion? In this case, we have two nonmetals and there's no hydrogen, so it's not an acid. So I'm going to write nitrogen, but I have two of them. So dinitrogen. And then you eyed the second guy. So we have four of them, tetroxide. Here we've got 6 phosphorus, so that's hexaphosphorus tribromide. Again, IDE, the second guy, bromide. Here I've got 2 silicons and 2 oxygens. With the metal and the nonmetals, we were able to like reduce these. We don't do that here, okay? So we have to keep the 2s preserved. So I would call this disilicon dioxide. Any questions on that? I think those are a lot easier to do, in my opinion, than the other ones.
So on tetroxide, if the prefix ends with an A and then
Yeah, sometimes they get dropped. I'm not going to be super anal about it. There won't be one that's like tetraoxide and tetroxide. Okay. Let me give you just a couple going the other direction. So I'll give you the name of a couple things and you just write the formula for it. Let's say we have tricarbon pentachloride and tetrasulfur monofluoride. All right, so for this first one, we've got tricarbon, which means I have 3 carbons. Pentachloride, I should have 5 chlorines. C3Cl5. As far as like what goes first, whatever they say first will go first. Carbon is more metal-like than chlorine. Sulfur, I've got 4 of them. Fluorine, I've got 1. Okay. So I think the most difficult thing happens not in the individual parts, but it's when they all get smushed together, right? Because it's like, what technique do I use to name how? So have that flow chart here ready at hand so that when you go to name something, you can just follow the system. I'm going to give you all a couple jumbled together, and I want you to give me the name of them. I'll give you the name and I'll have you write the formula, and then I'll give you a couple formula and have you write the name. So, And just so you know, the last little bit of the chapter is about organic naming, and we're not going to do that right now. Okay, so your test won't cover that, but it will cover everything else. So looking at this first one here, I've got lithium chloride. So this is a metal combined with a non-metal, and the ending is IDE. So I know it's talking specifically about chlorine. So Li has a plus charge, chlorine, Cl has a minus charge, so it should be LiCl. Lithium chlorate. Oh, it looks really similar to this one, but it's different in that it's ending in ATE. So I know I'm dealing with lithium and ClO3 minus. All right, flip flop, I get LiClO3. Iron 2 bromide. So I'm dealing with iron, and I have a 2+ charge. That's why the writer had to put the 2+ in there, because otherwise you don't know what the charge is, right? Bromine, Br, minus charge, flip flop. We should end up with FeBr2. Okay, the 2's coming from this thing here. Iron 3 sulfate. So I'm dealing with iron, Fe, and people will ask me, well, where? I don't know what the charge is on iron. I'm looking at my periodic chart and it's not on there. That's why it's written here, okay? So that's 3. Sulfate is SO4 with a 2- charge. Again, clump that together. Flip flop. We should end up with Fe2 parentheses SO4 parentheses 3. Last one here, sulfur trioxide. We've got sulfur, we've got oxygen, and there are 3 oxygens. So I know that it's 1:44. I'm gonna write a couple going the other direction. If you've got to go for it. This will get posted sometime later today, so you can check in. Otherwise, feel free to stay and hang out with me for a little bit, and we'll do some more practice with nomenclature. Do the nomenclature mastering chemistry before you take this next test, okay? And make sure you get the test done. I will be around Sunday evening as well, and then I'm around on Monday all day, so you can text, bother, if you want a Zoom meeting or something, let me know. All right, so for the people who are leaving, see ya. Otherwise, I'm going to move this over a little bit. I'm going to give you some going the other direction. So I'm going to write formulas, and I want you to give me the names. So CA. Sorry, guys. Try and write that a little clearer. CaNO32. Br2F3. ZnSO4. H3 HGS2. Okay. Why isn't the first one tetraoxide?
That was from earlier, and Brittany asked the same question. You answered it.
Okay, sorry. It's
Yeah,
sometimes
no
it's hard to lecture and keep track of everything.
I'm sure, no worries.
I'm gonna put one more at the bottom here too. H. Just another 30 seconds and I'll go through them. Okay, so with nomenclature and naming, with this whole thing, practice, 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 practice. And since you guys are doing it online, you're getting a little extra help. You don't normally get to have this flow chart. So you get to use it. So use it during the exam, okay? I want you guys to use it so you have the system. So first one here, this is a metal combined with a non-metal, specifically a polyatomic ion. Calcium has a predictable charge, so I know that I don't have to write like calcium 2 or whatever. I can just write calcium. All I have to do is say the name of the polyatomic ion, so calcium nitrate. And we're good, we're done. This guy here, bromine and fluorine are both non-metals, but it's not an acid because there's no hydrogen. So this guy, we're going to use prefixes. So I'm going to call this dibromine trifluoride. Dibromine trifluoride. Next guy here, we've got a metal combined with a polyatomic ion. Does this metal have a predictable charge? Yes. Zinc is one of those ones that I want you to have memorized. Aluminum, zinc, silver, 3, 2, 1. So this thing has a 2+ charge. So I don't need to say zinc 2. I can just write zinc and then the polyatomic ion, sulfate, zinc sulfate, and we're done. This guy here, metal and a non-metal. This metal has an unpredictable charge. So this one needs a Roman numeral. So we're going to write mercury. I'm going to put my Roman numeral in, and then I'm just going to finish up with that. That's sulfide. Sulfide. We're talking about the atom sulfur, so I IDE it. Now I've got to go back and figure out what charge is my mercury. So in this case, sulfur always has a 2- charge, and I have 2 of them for an overall 4- charge. This has to be 4+, so this should be mercury 4 sulfide. Last one down at the bottom is an acid. Hydrogen comes first, you classify it as an acid, and I've got this thing called nitrate. So when there's a polyatomic ion, I don't say hydro, I just look at what the Polyatomic is if it's 8, I ate something icky. So nitric acid. And we're done. Okay. So that's where I'm going to stop. That's where lecture ends for this stuff. You don't need to know the organics. There's like 2 more slides on there about organic naming. Don't worry about that for now. If you have questions, stay around. I'm here to hang out for a little bit. I know that was a lot of information. So yeah, feel free to hang out and ask questions. Otherwise, I will see you guys next week, or I'll chat with you through email. Okay. Cool.
Thank you.
Yep, bye. And I'll keep my screen sharing in case there's like a specific thing you want to work on or a specific one you want to do. Okay. You have a good weekend too.
Hi, thank you.
Bye. Cool. So I'm not going to put you guys in a private room unless it's like a personal question, but if it's like a lecture question, you can just ask me.
Mine is just a little, isn't our experiment this week or our lab this week, it's from the online book, not from?
Yeah, it's a mastering chemistry homework assignment. And it's going to be all of this stuff. It's all nomenclature naming stuff. That's why I want you to do it before you take the test.
All right, thank you. Have a good
Okay.
week.
Okay. Emily, Miles, you guys have a question? No? Emily, you got anything for me?